Hello everybody, in the video today we're going to take a look at an example of a differential equation using the method of integrating factors. So here's our example: x times dy dx plus 6y equals log x over x. So let's take a look at this. Okay, so the first thing we need to know is the general form for solving problems using the integrating factor. That is as follows. We should have dy dx equals p of x times y, all equals q of x. So what we have is dy dx is on its own, p of x is the function of x that sits in front of y, and all the x's that are on their own sit on the right hand side. Okay, so we look at our problem, we can see that we don't have dy dx on its own because of this x, so we're going to divide that out. And we have dy dx is plus 6 over xy equals log of x divided by x, the same as divide by x squared. So from this we can see that p of x is 6 over x and q of x is this thing here, log of x over x squared. Okay, so we got it in our general form. The next thing we need to do is find the integrating factor, ix. The definition of this is e to the power of the integral of p of x. So let's calculate that. So e to the power of the integral of 6 over x. I'm going to move the 6 to the front because it's a constant, and I'm left with integrate 1 over x, which is log of x. So the integrating factor is e to the power 6 log x. Notice here we don't need to add the c, we'll deal with that much later. Okay, what we want to do next is cancel off the logs and the e's. So really I want to use this rule that e to the power log of some number, let's say a, is just a, just cancel them off. So this is what I want to do. In my case, the 6 is in the way, blocking this cancellation process, but using the property of log, I can move that up to the power, like so. 6 goes on to the power of x. Now I can cancel them off, giving me x to the power 6. This is my integrating factor. Okay, so now we calculated that. The next thing we need to do is multiply through, so this equation here, multiply through by I, which is x to the power 6. Okay, so let's do that next. Okay, so what are we going to have? We're going to have x to the power 6 dy dx plus 6x to the power 5 times y equals log of x divided by x squared times x to the power of 6, which just cancel out to x log x, x to the power of 4. Okay, so there's a special reason why we do this, and that is because the left hand side will always appear as the product of two functions. You see the product rule here, so we can see if I give this some name, if I call this a let's say f, then I can see this one here is its derivative, and if I call this one say g, this one here is its derivative, And this looks very much like the product rule. This always works. This is always true. So actually, the left-hand side, we can think about it as factorizing. And it factorizes to the integrating factor times y. And this is always true. It's always ix times y. Okay, how about the right-hand side? Well, we have log x to the 4. We now need to solve this problem. And our answer just sits here. This is what we want. Okay, so firstly, we need to remove the d by dx here. We can do that by integrating both sides with respect to x. So that will leave x to the 6 y equals the integral of log x to the 4 with respect to x. Okay, so now I'm left with this integral. Doesn't look too simple. We need to think of some ideas here. Okay, so what techniques do we have for integration? We have substitution. Nothing jumps out here. We have parts. This is for a product. Well, this works quite well because we have a product here, something times something. With a little bit of thought, we should use parts and we should label log x as u and x to the power 4 as v to the x. Okay, this will all become clear when we get stuck into the formula. So let's do that next. So we have our u is log of x and dv dx is x to the 4. So if we differentiate u with respect to x, get 1 over x. And to find v from dv dx, we need to integrate. So x to the power 5 over 5. Put this into the parts formula. We have uv, so log of x times x to the 5 over 5, minus the integral of, let me see, du dx, which is 1 over x times v. Well, that's quite nice. This simplifies down to x cubed, which is quite easy to deal with. So we have x to the power 5 over 5 log x. Okay, so what do we have here? Oh, hang on, this is not right. This should be v. This is x to the 5 over 5. Yeah, that's better. Okay, so to simplify this in here, we have x to the 4 over 5. I'm going to integrate that with respect to x. And the right hand side, sorry, the left hand side is the integrating factor, which was x to the 6 times y. Okay, we're almost there. So the first term is x to the power 5 over 5 log x. Integrate x to the power 4 over 5. So upper power divide by the power. 5 times 5 on the bottom is 25 plus c. And finally, I'm going to divide through by x to the power 6 to get y on its own. And we get, let's see, we get 1 over 5x log x. Take away 1 over 25x plus c over x to the power 6. And this is our final answer. And there you go. We have our solution. It's a general solution. You see our constant there. to our original differential equation.